Okay, so have you ever, like, really stopped to think about how AI actually reads and writes?
It really is kind of mind-boggling when you actually try to wrap your head around it.
Right. Like, how does it go from just this jumble of letters, zeros and ones, whatever, to, like, generating Shakespeare?
Or even just like composing a coherent email. Sometimes that's impressive enough, right?
Totally. So that's what we're going to dive into today, this whole hidden world of LLM tokenization.
We're going to figure out why it matters, how it works, and ultimately how it explains so much of the, I don't know, magic of AI.
Magic, the mayhem.
Exactly,
Yeah.
because sometimes it's not so magical, right?
Definitely not. Okay, so to really break this down, we've got articles, code examples, research papers, all that good stuff.
We're talking about the core building blocks of how AI actually understands language.
Which is,
Tokens. And spoiler alert, it's not as simple as just, words.
oh, I bet it gets complicated. Probably a little frustrating at times, right?
More than a little. But that's why we're here. We're going to go from AI ABCs all the way to understanding why it can write you a sonnet but still fail that coding interview.
Uh-huh. Yeah, seriously. It's like, how does that even happen?
It's all about the tokens.
Okay, so let's say you're building, I don't know, AI Shakespeare. Where do you even begin?
Right. How do you teach a computer a language?
Yeah, it's not like we can just hand it a dictionary and be like, go wild.
Although that would make things a lot easier, wouldn't it?
Ways easier.
But no, it's way more complicated than that. It's tempting to think, okay, we'll start with the letters, right?
Yeah, ABC.
Exactly. Just like we learned as kids. And actually, some very early models, that's kind of how they did it, this character level tokenization.
Now, they were literally starting from scratch.
Pretty much. But there's a catch.
There's always a catch. What is it?
Well, think about it. The English alphabet alone, that's 26 letters, times 2 for uppercase and lowercase. Then you add in punctuation, special characters.
It adds up fast.
You end up with this massive vocabulary before you've even taught the AI a single word.
Wow. So it's like trying to cram an entire encyclopedia into your brain all at once.
Yeah.
No wonder AI was struggling.
Exactly. Computationally, it's a nightmare. So that's where subword tokenization comes in.
Subword. Okay, break that down for me.
It's about efficiency, right? Instead of individual letters, we teach AI to recognize common chunks of language. Like, think of it like compressing a file on your computer.
Okay, so instead of storing encyclopedia as like a million little pieces, it's more like encyclopedia.
You got it. And there are algorithms that figure out the best way to do this. One of the most famous is called Byte Pair Encoding, or BPE.
Byte pair. Okay, I'm going to need an example for this one.
Sure, let's say we have the word encoding. A BPE algorithm might notice that encod and ing often appear together.
Smart.
Right? So instead of 6 separate letters, it creates 2 tokens, encod and ing.
So it's like learning those prefixes and suffixes we use all the time, building with Lego blocks instead of individual grains of sand.
Exactly. Much more efficient. But here's the really cool part. By recognizing these chunks, AI starts to pick up on grammar and sentence structure.
Whoa, so it's not just about efficiency, it's about actually understanding the language in a deeper way.
You got it. It's a massive leap from just identifying individual letters.
Okay, so that makes sense. But if AI is thinking in these chunks, in these tokens, does that explain why it still messes up sometimes?
Okay, so AI is picking up on these chunks, these tokens, and it's starting to see the patterns in language. But if it's so good at that, then why does it still trip up on things that seem, kind of simple to us?
Well, that's where things get even more interesting. Remember how we were talking about AI being like magically smart and bafflingly dumb at the same time?
Oh, absolutely.
Tokenization helps explain that paradox.
Okay, I'm intrigued. So it's like, write me a sonnet, no problem. But ask it to spell banana.
And it might just fall apart.
Exactly.
It's all about how those tokens are actually processed. There's this really cool tool online, the Tick Tokenizer web app. I don't know if you've ever played around with it. I think I've seen it, but I haven't really spent much time with it.
It lets you visualize tokenization in action. So let's say you type in Python, like the programming language.
Okay, got it.
Now type it again, but put a space before Python.
Okay.
Different token. Now try it with a capital P.
No way. Seriously.
Seriously, it's like the AI is thinking, hold on, these are completely different pieces of information.
Even though to us, it's just Python, however you want to write it.
Exactly. And here's where that whole AI brilliance meets weirdness thing comes in. Those early GPT models?
Yeah.
They actually struggled with basic Python code because of this.
Wait, really? Because of a space?
Because of tokens. Every indentation level in the code, every space created a whole new token. It ate up their token budget incredibly fast.
Token budget. Is that like AI's allowance for thinking?
That's a really good way to think about it, actually. AI has a limited number of tokens it can juggle at once. It's short-term memory. We call this its context window.
Okay, so it's like the size of its mental scratch pad.
Exactly. GPT-2, for example, had a maximum of 224 tokens it could hold in mind at any given time.
Got it.
Now, GPT-4 comes along, and it's essentially doubling the size of that scratch pad. But it's not just about adding more slots. It's about making each slot more efficient.
Okay, so bigger isn't always better. It's about using the space you have more effectively.
Precisely. Remember that example of encoding being broken down into encode and ing?
Yeah.
Imagine that, but on a much larger scale. GPT-4 has a larger vocabulary, something like 100,000 tokens, which allows it to represent information more densely.
So it's not just memorizing more words, it's understanding the relationships between them better because it has these denser chunks to work with.
You got it. And that directly translates to a larger context window. Even if the raw token count stays the same, GPT-4 can think about more complex ideas because it's not wasting space on inefficient representations.
This is blowing my mind. So bigger vocabulary, denser tokens, bigger context window, smarter AI. But like any good upgrade, I got to be a trade-off somewhere, right?
There always is. In this case, it's computational cost. Remember those embedding tables we talked about, where the AI stores what each token means?
Yeah, it's like its own internal dictionary.
Right. Exactly. The larger the vocabulary, the bigger those tables get. Think of it like a giant spreadsheet. Each row is a token, and the columns are all its different meanings and relationships. More tokens, more rows, bigger spreadsheet. And that means more processing power, more memory, higher computational costs to make it all work.
So it's a balancing act. Denser tokens for smarter AI, but you pay the price in computational cost. It's like trying to cram a supercomputer into a smartphone.
And that, my friend, is the fascinating challenge of AI development. It's not just about building bigger models. It's about smarter tokenization, better algorithms, squeezing every ounce of performance out of the system.
Okay, so we've gone from single letters to these super efficient token chunks, all in the quest to make AI understand us better. But where do we go from here? Is it just about even bigger vocabularies, even denser tokens, until AI can practically read our minds?
Well, that's the million-dollar question, isn't it? But here's where things get really interesting. Text is just the beginning. Remember how we talked about those token IDs, those numbers that represent each chunk of language?
Yeah, like AI's internal code for cat or existential dread.
Right. Exactly. What if we could do that for everything? Images, audio, even video. Turn all of reality into a format AI can understand. That's the mind-blowing potential of multimodal tokenization.
Hold on. So instead of just reading Shakespeare, AI could watch a movie, listen to a symphony, even experience a sunset, all broken down into these token building blocks.
You're getting it. And it's already happening. Those AI-generated images that are everywhere these days, they work by training AI on massive data sets of images that have been broken down into visual tokens.
Wow, so from an AI's perspective, a Van Gogh painting might not look that different from, say, a Shakespearean sonnet. It's just different patterns of tokens, different ways of encoding information.
You're starting to see the bigger picture, and it's both exhilarating and a little daunting.
Because it means we're teaching AI to experience the world in a way that's fundamentally different from how we experience it.
Exactly. And that's why understanding tokenization is so important. It's not just a technical detail. It's about shaping how AI perceives and interacts with the world around us.
So we've gone from ABCs to AI experiencing sunsets, all thanks to these tiny but mighty tokens. Who knew they were the key to unlocking so much of AI's potential and its quirks? So from AI reading code to like potentially experiencing a sunset, it all comes down to these tokens. But if we're already teaching AI to kind of see and hear using tokens, what's next?
That's the really exciting part. We've talked about how efficient GPT-4 is with its tokens, right?
Right.
Imagine if we could push that even further.
Even denser tokens, more efficient encoding. Like, what are we going to start measuring these things in? Like bits of fairy dust next?
Not quite, but some researchers are wondering if we can ditch tokenization altogether.
Wait, what? But I thought tokens were the whole point.
They are, for now. But imagine feeding raw data, like the raw information from an image or a sound wave, directly into the AI. No more breaking it down into these intermediary chunks.
So instead of translating everything into AI language, we're teaching AI to understand the world in its rawest form.
Exactly. It's like the difference between reading a translated book and like experiencing the story firsthand in its original language.
Ah,
That's the holy grail, and it could change everything.
that's mind-blowing. But for now, it seems like tokens are still the name of the game.
Right, and understanding them is key to unlocking the power of AI, from understanding its quirks to imagining its future possibilities. It's not just about the technology, it's about what we can do with it.
So we've gone from those very first attempts at teaching AI the alphabet to AI potentially experiencing the world kind of like how we do. And it all comes back to these tiny but mighty tokens. Who knew they held the key to understanding so much about AI? It's wild. We've gone from AI ABCs to AI sunsets, and honestly, I'm excited to see where these tokens take us next.
Me too. It's going to be quite a ride.